Greetings all. In this video, I'd like to do an introduction to momentum. What we're going to do is define momentum and impulse. We're going to explore why physicists care about this concept called momentum, where it comes from and what it is. And then finally, we're going to calculate the momentum and impulse for different objects here. So let's get to that second point. Why do we care about momentum? Let's think about this with a little bit of a thought experiment here. So let's say two students want to do an experiment with Mr. Baker's car here. The first student says, hey, look, I'm going to throw a 5-kilogram bowling ball at Mr. Baker's car. And let's say they can throw it at like 1 meter per second. Student 2 says, instead of a bowling ball, I'm going to use a golf ball. We'll say that golf ball weighs like 0.1 kilograms, but because it's lighter, they can throw it at like 50 meters per second. The question we want to ask is, which ball is going to do more damage to the car? Which one has a greater impact there? Well, you might think, well, the bowling ball weighs more, right? It has a greater mass, more inertia. Maybe that's going to do more damage. But the golf ball is traveling a lot faster, right? 50 meters per second versus 1. It's going a lot faster. Which one of those do we think actually matters more? Well, early scientists were also interested in this, thinking about how mass and velocity both seem to matter when it comes to collisions and things like that. They used to call this impetus, actually. I think it's a good word, impetus, to think about, what's the impact of this here. But we have a different word for this. We now think about the concept called momentum, and it takes into account both of these. Let's take a look at the definition here. Momentum is the product of an object's mass and its velocity. So in that last example, both the golf ball and the bowling ball, when you took their mass times their velocity, give you 5. So they both have the same momentum. And so we'd say in this collision, they're going to kind of have the same impact. Now, there's some other things that might be involved, but momentum-wise, they have the same momentum. Even though they have different masses and different speeds, the product is the same. Another way to kind of think about momentum is that it is inertia in motion. It's a mass that also has a velocity. It takes into account both of those things. Now our symbol for momentum, we're going to give it the symbol P. And the equation is going to be that momentum, P, is mass times the velocity. So P is our momentum, M is our mass, and V is our velocity. Now our units here, mass is measured in kilograms, velocity is measured in meters per second. And so when you take the mass times the velocity, we're going to end up with kind of a weird unit. Momentum is typically measured in kilogram meters per second. So just the product of those, kilograms times meters per second here. Let's take a look at examples of how you're going to calculate this. So our example, first one, says which of the following has more momentum, a Mack truck sitting on the road or a small bullet fired at 1,200 meters per second, and why? Well, if we think about these, our truck here is just sitting on the road. We don't know what its mass is, but we know that its velocity is 0. If its velocity is 0, when you do P equals mv and plug in 0 for v, for P, you're going to end up getting 0. So this one has a momentum equal to 0. Now for our bullet here that we're firing at 1,200 meters per second, I know v is 1,200 meters per second. And mass is going to be small. But whatever that mass is, I don't know what it is, it's going to be larger than 0. And so this P has to be greater than 0, and so my small bullet is going to have a greater momentum. So don't be tricked. Even though the truck weighs a ton, it has a lot more mass than the bullet can have a bigger momentum if it's going fast enough. And so here, in this case, it's going to have a non-zero momentum. Number 2 here says, what is the momentum of a 0.4 kilogram baseball moving at 30 seconds, or 30 meters per second? To calculate this, our equation, P equals mv, go ahead and substitute with units. P is 0.4 kilograms times our velocity of 30 meters per second. If you do that calculation, 30 times 0.4, you're going to end up getting 12, and our unit for momentum, kilogram meters per second. A second example here with the calculation, momentum of a 15 kilogram object moving at 12 meters per second. You might want to try this one on your own. Pause the video first and see if you get the same answer. If I do it here though, P equals mv. P is 15 kilograms times our speed of 12 meters per second. 15 times 12, you do that in your calculator, I end up getting 180 kilogram meters per second. So that's how we're going to calculate momentum. Just P equals mv, very simple equation, not very different than things we've seen before. The next concept I'd like to talk about then is, well, what happens when an object changes its motion? How does that impact momentum, and what do we deal with? How do we deal with that? So the way we deal with that is this new concept called impulse. Impulse is defined as the change in momentum. So our impulse, which is unfortunately given the letter J and not I or anything like that, impulse is J, and it's defined as the change in momentum. Now remember, in physics, if J is the change in momentum, we can write it like this, and this equation's in your reference table, J equals delta P. But delta in physics, a change always means final minus initial. So another way we can write this, that I would like you to write it, is saying that this is equal to the final momentum minus the initial momentum. J is P final minus P initial. And then we know what momentum is equal to. Momentum is equal to mass times velocity. And so I can go ahead and say that J would be m times the final velocity minus m times the initial velocity. Now you can use these equations any way. You could think of it as delta P and just know that change in momentum, final minus initial, or you could think of it like mvf minus mvi here. Let's take a look at how you'd use this. An example problem says, what is the impulse implied to a 980 kilogram car as it goes from rest to a velocity of 15 meters per second? Well, I want to calculate my impulse, and impulse is the change in momentum. Now let's go ahead and list some variables out. I know my mass is 980 kilograms. I know it's going from rest, so its initial velocity is 0 meters per second, and the final velocity is 15 meters per second. Now, to expand my equation, it's final minus initial. So my impulse is going to be P final minus P initial, and that's going to be mv final minus mv initial. Plugging in my numbers, m is going to be 980 kilograms times my final velocity of 15 meters per second. And I'm going to subtract off there my 980 kilograms again times 0 meters per second. If you plug those numbers into your calculator, you're going to end up getting, I end up getting for J, 1,408.80 kilogram meters per second. So that's impulse for you. Just the change in momentum, find the initial, find the final, plug into the equation, and solve. Thank you.